periodic table is your best friend in chemistry. I tell my students to name theirs. This is because your usual friends can't help you in exams, but the periodic table can if you know how to use it. Though much work had been done before, the first recognisable periodic table was drawn up by the Russian Dmitry Mendeleev in 1870. Apparently he put the known elements on cards and played around with them until he could see the patterns. First, he put all the elements in order of atomic mass. However, this gave some anomalies, things that didn't fit the pattern. For example, iodine was in the same group as oxygen and sulphur, which did not make any sense because iodine was much more like fluorine, chlorine and bromine, all forming 1- ions like iodine does. Tellurium, next to it, should have been underneath selenium, in other words in the same group as oxygen. They all form 2- ions. So, bravely, Mendeleev decided to swap iodine and tellurium round, so it was in the same group, which all form the same number of ions. This makes much more sense. He also left gaps for elements that hadn't yet been discovered, and he predicted what they might be like. For example, he predicted an element called Eka silicon, and it should be a grey metal with a mass of around 72, and it should be under silicon in the periodic table. When germanium was discovered less than 20 years later, which was a soft grey metal with a mass of 72.3, it was realised that Mendeleev's periodic table worked, as it could make good, useful predictions. When the structure of the atom was found, the periodic table made much more sense, as it could now be put in order of the number of protons. This is called the atomic number, as the number of protons is what affects how an element reacts. This is because it affects the number of electrons, and if something has the same number of electrons, it will react in the same way. This means the periodic table can tell us how many particles any particular atom has. For example, sodium has 12 protons, the number shown as in the key as the atomic number, and it is the number of protons. It is always the smaller number. Atoms are neutral, so it must also have 12 electrons to balance the charge. The mass on the periodic table is the relative atomic mass, which is the average mass of a mole of atoms. We don't need it here at the moment. So long as an atom has the correct number of protons, it will have the same reactivity. Isotopes have the same number of protons, but a different number of neutrons. Only the number of protons affects reactivity, so if there are more or less neutrons, it will only change the mass. For example, heavy water has 2 hydrogen H2 isotopes. They have an extra neutron, and 1 oxygen atom, instead of 2 normal hydrogen 1 isotopes that only have a proton. This makes the mass 20 instead of 18 of the whole molecule. However, in every other way, the water is the same. You could even drink it. Another example is chlorine, where some of the atoms have 18 neutrons and some have 20. As chlorine has 17 protons, this means it can have isotopes with mass 35 and some with mass 37. They react in the same way, but they have different masses. So the periodic table can tell us how to work out the number of protons, neutrons and electrons in any given atom. The number of protons is always the same as the atomic number. The number of electrons in a neutral atom is the same as the number of protons. You have to work out the number of neutrons. Because neutrons have the same mass as protons, they add up with the protons to make the mass number, so all you have to do is to take the number of protons from the mass number to give the number of neutrons. Oxygen, in this example, oxygen 16 has 8 protons, so the oxygen 16 isotope must have 8 neutrons and 8 electrons. Another example is carbon-14. How many protons, neutrons and electrons does it have? Well, the periodic table tells us that carbon has 6 protons, which you can see there. The atom is neutral, so it must also have 6 electrons. The mass that we are given is 14 of the isotope, so it must have 14 minus 6, which is 8 neutrons.